All right, so this is a quick video about domain and range. You might remember a little bit about this from Algebra 1. So domain, these are kind of about graphs. So we'll be looking at graphs. It's not all about graphs, just easiest to see with a graph. So the domain is the x values that the graph of a function is going to include, and then the range is the opposite of that, the y values that the graph of a function will include. So we're going to look at some graphs and see what x's get covered by the graph and what y's get covered by the graph. All right, so I've got two functions up here. One's an absolute value, one's a linear. Okay, and we're going to remember that domain, these are the x's that we're looking for, and range, we're looking for the y's. So if I think about the x's, I'm going to use this highlighter bar, get it back here. Imagine that I'm all the way back on the graph, as far back as it will go. So I know that I'm getting covered by the graph all the way back there, all because this, remember, this absolute value really extends back for forever. So I'm back here on my x-axis, and I know I'm going to get covered the whole time. As I follow my x-axis forward, 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 I'm covered by the graph, covered by the graph, covered by the graph, and it goes on forever. So no matter how far forwards or backwards, I will be covered by this graph. So really, there is no restriction on our domain. We go back for forever and forward for forever. Remember, x goes back and forward. So our domain of our x's, we're going to say, is all real numbers, and that just means all the numbers you know so far. And sometimes you'll see that abbreviated with an R with two kind of lines to start the R. And sometimes, if you remember from Algebra 1, we did it as an interval. We said we go back as far as negative infinity and we go forward as far as positive infinity. That last one's called interval notation. So you'll see that kind of as we go. I'll try and do a couple different forms. And I don't really care which one you use. I just want you to see them all for the ACT, really. Okay, y values now, so the range. So I'm going to go down as far on the graph as I can, since y goes up and down. As far down as I can. That absolute value is never going to be down here. The first place that I get to my absolute value is when I cross up here at 3, right? When I finally, or I'm sorry, -3. And then once I pass -3 and keep going up on the y-axis, I know that these arrows are going to tell me that this absolute value is going up for forever also. So let's do that again. So from down at negative infinity, I got nothing, 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 nothing. And then at -3, I start to pick up the graph. And then it goes on and it will go up forever. So from -3 up. So here are a few ways to write this one. So this one actually has a restriction. We can't say all real numbers. We could say that the range exists everywhere that y is greater than or equal to 3. And if you see some hardcore math, you may see it written like this. The set of all y's such that, that bar that I just put in is such that. The set of all y's such that y is greater than or equal to 3. That's called set notation. And again, I don't care if you do that. I just want you to be able to see it. So I'm going to do some set notation today. Also, I'll be doing interval notation. That's the one I mentioned before. So interval notation. That's where we would say, go back to this graph, we had nothing until we got to -3, and then we would go up on the graph all the way up to positive infinity. And we would be covered from, and here's how we would write it, -3 to positive infinity. And because -3 was included, you use a bracket instead of a parentheses. So let that sit for a while. Let me do a few more and you might see the deal with the bracket and the parentheses. Bracket just means you include -3, that at -3 were included. It's kind of like the open and closed circles. So that bracket's kind of like a closed circle. All right, so domain x's, range y's. Let's do another one. I know this is a little weird. I'm going to take my little bars over. Okay, so let's start with domain. That's the x's here on this linear. Remember, x's go, the x-axis goes right and left. So I'm just going to follow along on my x-axis. So it looks like I'm not on the graph right now, or that my line is not going to cover my little highlighted spot, but I know that it goes, this line goes back for forever. So I know I'm back, I'm on the graph, it's just high and off the graph. So I'm on the line, 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 I'm on the line. Basically, I'm always on the line. No matter how far back and how far forward I go, the line goes with me. So there is no restriction on the x's. I'm always on the line somewhere. So all real numbers, or remember we can call that double R, or we can say no restriction means that I go from negative infinity to positive infinity and I'm always on, there's always an x value covered. Okay, y's. So remember, y's go up and down, right? Up and down are y's. So if I'm way down here at negative infinity, I know that I'm on my graph over here to the right. And as I go from negative infinity up to positive infinity, I'm still covered by the line the whole time. The line's still there, and I know that it will go up for forever, that line will. So there is no restriction on the range either. Remember, range is y's. So if there's no restriction, we say all real numbers. We can say that double R, that means all real numbers also. And then we could do interval notation. Okay. All right, let's try another one. So I put on two graphs you might remember from Algebra 1. That first one is an exponential, second one is a quadratic. All right, let's go to this exponential. So let's think about our domain, which is our x's first. Remember, x's go, the x-axis goes forwards and backwards. So I'm going to trace forwards and backwards. So when I'm back here, way back at negative infinity, since I know this exponential goes on forever back there, I know that I'm covered by my line all the way even back there. Covered, 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 covered. And this end, I know that this graph is going, it's going up, but it's also going out, so that it continues to go out the whole time also. So as far back as I go, I'm covered. As far forward as I go, I'll be covered. That means there is no restriction. So again, we'll say all real, oops, let's fix that. Let's not mix words. All real numbers. We could do our double R, or we could do our interval notation. Any one of those three things. Okay? Now, our range, that's our y's, how far up and how far down, oops, how far up and how far down this graph is going to go. So I'm going to start down at the bottom in the negatives. So think about what you know about exponentials. It's been a while, but do you remember that there's an asymptote right here? That our graph kind of gets close to that asymptote but never actually touches it. So I know I'm never going to be below that. So no matter how far down I am here, down at negative infinity, as I start to trace up, I'm not on the graph, not on the graph, not on the graph, until I get to -5. And technically at -5, I'm still not on the graph because that's the asymptote. But just above -5, I'm on the graph. And then I'm on the graph, on the graph, on the graph the whole time up. All the way up to positive infinity, way up there. So let's do it again. Off the graph from negative infinity. At -5, I'm technically off, but then I'm on. And then all the way up to positive infinity, I'm on the graph. So let's think about how to write that. So we could say that y's start picking up when y is greater than 5. We will not say greater than or equal to, because that would say that at 5 we're on the graph, but we know that's the asymptote, so take that off. So y is greater than 5. If you were doing true set notation, it would say, here's your set, the set of all y's such that y is greater than 5. That's true set notation, but it really just means y has to be greater than 5. And then interval notation, so we're going from, at 5 is where we pick it up, and we go all the way up to positive infinity. And since 5 is not included, I don't want to use that bracket. Remember, that's like a closed circle. So I'm going to take that off. So from 5 to infinity, infinities always get parentheses, and I need to use a parentheses to show that 5 is not a part of my range. If I used a bracket, I would be saying 5 is part of my range, and it's not because that's the asymptote. Okay, let's try again. Let's do another one. So this next one is absolute, nope, not absolute value, quadratic. Let's go ahead and do our domain, which is x's. So x's, remember, go forwards and backwards. That's where the x-axis goes, forwards and backwards. So even though it feels like right back here I get off my graph, I know that this graph is still going out. I know it's going down, but it's also going out. Same thing up here, it's going down, but it's also going out. So I'm still going, still going backwards, and I'll still be covered. It's just down off the graph. And as far forwards as I go, I know I'm still going to be covered out here because that graph is always going out further and further. Always going back further and further, always going forward further and further. So no restriction on our domain. So we will say all real numbers. Or you can give me the double R, or you can say that the domain goes from negative infinity to positive infinity. All right, what about our range? I'll steal this. So remember, range is y's. They go up and down. So when am I covered? So let's always start down in the negatives. So at negative infinity, I know I'm covered by that graph because it goes down forever. So I'm covered the entire time until I get to 7. I'm still covered at 7 because that's a solid point up there. And then as soon as I pass 7, I'm uncovered. So I have to be less than 7 to be in my range of this function. This range goes from negative infinity all the way up to 7 and then stops, and then I'm off the graph. So let's figure out how to write that. So now, to be on this graph, our y's, you have to be less than or equal to, since it was a solid dot, 7, because that's as high as it will go. Again, if this was set notation, we'd say the set of all y's such that y is less than or equal to 7. That's set notation. Interval notation, let's see, our cutoff, we go from negative infinity and we get cut off at 7. Okay, infinities always get a parentheses. 7 is included, that's the or equals to, so I need to use a bracket. Okay? So, when you do your worksheet, I don't care which of these 3 ways you write things. You can do just an inequality, you can do true set notation, or you can do true interval notation. I'll make sure that the key has all 3, and you can kind of compare. Do make sure you're a little bit comfortable with all 3, just in case you see something like that on the ACT. That needs to be an easy question to get right on the ACT. Okay, that's domain and range.